Hi friends, welcome back to CADable. This is Engineer Ibrahim Omer, and in this tutorial we will perform a static structural simulation of this cantilever beam in Solidworks. The simulation will help us in understanding how our parts behave when a load is applied on it, whether this part is going to fail or not, how much it deforms, where the stresses are highest, and whether the design meets our requirement or not. So let's go to SolidWorks and let's learn this. So here you can see that we are using SolidWorks 2020, but if you are using a below version of SolidWorks or a future version of SolidWorks, you can still follow this tutorial. So first of all, I will go to here New, select Part and select OK. And now we are in SolidWorks interface. So first of all, as usual, I will change my background to plain white. And I will set my units to mmgs, that is millimeters gram second. The first step is to create a geometry. We can either create geometry or we can import geometry. So in this tutorial, we will create the cantilever beam. I will select front plane, sketch, and here we will create two rectangles. One center rectangle like this, and another center rectangle like this. I will use trim tool. I will delete these center lines. I will delete these lines. In fact, I have to trim this line as well. And we will delete this point. Okay. Now I will give it necessary dimensions. So this length is 250 millimeters. This height is 150 millimeters, and you can see it is not symmetric. So I will create one center line like this, and we will make it horizontal. Now it is symmetric. The thickness is 25 millimeters. It is also 25, and you can see it is still underdefined. So I will select this point, I will select this origin, and I will make it coincident. Now you can see that the color of the sketch is turned into black from blue, which means it is fully defined. I always recommend you to create fully defined sketches. You can see here as well, fully defined sketch. I will exit the sketch mode. I will go to here features, extruded boss, and here I will give it a thickness in both directions. Let's say 70 or maybe 80 millimeters, and select OK. So we are done with the geometry. Next is we will go to SolidWorks Simulation, and here you can see that I cannot see Simulation tab. So what you have to do is to go in this option, SolidWorks Add-ins, SolidWorks Simulation, and I will click here SolidWorks Simulation Premium, or you can click anywhere because it is static structural simulation. If you don't find this option, just go to this gear icon, add-ins, and here you can see this option SolidWorks Simulation. So I will go to here simulation, new study. And here you can see that we are given with different simulations like static structural, topology, design study, thermal, buckling, fatigue, non-linear, etc. So we are using static structural simulation. So I will rename it as cantilever beam. Cantilever beam CAE. CAE is computer aided engineering, which is also part of FEA. I will click OK, and now we are in simulation mode. So first option is to apply material, whether it is wood or metal or plastic. So for this, right click, go to here, edit, apply edit material, and here you can see we have a bunch of options: steel, iron, aluminum alloys, zinc, carbon, wood, rubber, silicon, even carbon fibers, etc. We can create our own material as well. So I will go to steel and then I will look for ASTM A36 steel, whose density is 7850 kilograms per meter cube. Here you can see different units: yield strength 250 megapascal, tensile strength 400 megapascal, Poisson ratio, etc. You can see different properties. Click apply and close. And here you can see material, this particular material has been applied to your geometry. Next is this option, connections. We use this option when we are dealing with assemblies, but because it is a single part, so I will not use this option for now. Next option is fixture, where from where your part is fixed. For example, if this is a cantilever beam, so it is fixed from here, okay, using bolts or using welding. So I will go to here, fixture, right click, and here you can see different types of fixtures. I will click here, fixed geometry, and under fixed geometry you have two more options, roller slider, fixed hinge. So I will use fixed geometry option. I will select this back face of the geometry and I will click OK. Here you are given with some different options as well, but I am using the standard option. Click OK. Next option is external loads. So whether you are applying force, torque, pressure, centrifugal load, temperature, etc. So here I am using force. You can apply force on this particular face, on this face, even on this edge. So I will be applying force on this edge, but here you can see the direction is not correct. So for this I will select this option, selected direction, and I will use this edge as vector. And here you can see the direction is changed. And I will change my force value to, let's say, 2000 Newton. And here you can change the units as well. You can change unit to metric or IPS. You can apply non-uniform distribution as well of the forces. And I will click OK. Next option is we have to mesh this model. We have to discretize it. For this, I will go to here, mesh, right click and click this option, create mesh. Mesh basically discretizes your geometry into finite parts. That's why it is called finite element analysis. So here you can see that we are given with three types of meshes in SolidWorks: standard mesh, curvature based mesh, and blended curvature based mesh. But because it is a simple geometry, so I will be using this standard mesh and click OK. And here you can see that our geometry has been divided into small rectangles, and these are called meshes. Next option is we have to solve the simulation. Go to here, run this study and click here. Now you can see we have different color contours, red color, blue color, green color, etc. And we have three results by default: stresses, displacement, and strain. So here are the results of our static structural simulation, and I will animate this. And here you can see when we are applying load in this direction from here, so the chances of material breakage is most likely from here, okay. So when you are applying load from here, so the chances of material breakage is most likely from here, okay. The red color contour is showing the maximum stresses and the blue values are showing the minimum stresses. So here are the minimum stresses, and in this direction, here are the maximum stresses. I will go to here stress, right click, chart options, show minimum value, show maximum value. I will change this from scientific to floating and I will change it to 0. And now you can see the maximum displacement, the maximum stresses are 56 megapascal from here, as I told you already. And the minimum stresses are here in this fixed side. But the displacement criteria is different. So double click it. And I will go to first chart options, show minimum value, maximum value. I will change it to floating. And here you can see the maximum displacement is here, okay, and the minimum displacement is here. Because the material is fixed, so there is no displacement. And here, as you can animate it, here are the maximum displacement. You can see it is 0.404 millimeters. Another important thing which I would like to mention here is the superimpose. So right click, go to here, edit definition, settings, and here you can check on this box, superimpose model on the deformed shape. So it will show you two different states. One is the undeformed and one is the deformed. And here you can see the material was here and then it is deformed here, but it is not a true scale, okay. Right click, go to here, definition, and here you can see that it is 62 times scaled. So whenever, when you click here true scale, 0.404 is a very less displacement. Software always gives you scaled value, so you have to check it. And next option is the strain. The strain is different from displacement. It is the deformation within the material, and its value are very, very small, like 0.004, 0.0025, etc. And the displacement is the absolute value. So displacement is like 0.5, 1 millimeter, 1.5 millimeter, but the strain value is very, very small. It is the change in length upon the original length. In stress analysis or in FEA, we mostly discuss about stresses and displacement. Now let's look at factor of safety. Right click and I will define factor of safety plot. Click here and select OK. So factor of safety basically shows the yield strength of the material divided by the material allowable stresses. So 4.4 basically means that material can withstand 4 times or 4.4 times more stresses, and this factor of safety plot is directly linked with stresses. So I'll go to here stresses, and here you can see this value and this value. So go to here calculator and I will divide 250 megapascal with this value 56, 632, 212. So I will come up with 4.4. You can see that. So this is the factor of safety, 4.4 over here. Okay. Lastly, we will look into another important result criteria, that is called reaction forces, and the reaction forces must be balanced. So I will go to here result, right click, and I will click on this option, list result force. So we calculate reaction forces on the boundary conditions. So we fixed our cantilever beam from here, and the applied force was 2000 Newton. So it must be 2000 Newton in order to balance the equation. So click here on this face and update. And here you can see the value is 2000.1. So 0.1 is the error, but it is correct. You can see the value is minus 0.14 and 0.025 something. So these are error, but our result is correct. The applied load was 2000 Newton and the reaction forces are also 2000 Newton. So basically it is a sanity check. So click OK. So that's how we calculate stresses, displacement, strain, factor of safety and reaction forces in SolidWorks. Here is an important message as some students were approaching me. If you do like some personal guidance, I offer one-to-one session for engineers, students on AutoCAD, SolidWorks, ANSYS, different engineering topics, assignments, and even in final year project. You can reach me through my email and I will be providing my email in the description link. So that's it for today's tutorial. I hope you like this short tutorial. Still, if you have any question, any query regarding this tutorial or any other tutorial in my list, you can ask me in comment section. Thanks for watching and please subscribe to our channel for more informative and interesting projects. I will see you in the next tutorial. Thank you.